this lesson, we're going to look at the product rule and the quotient rule for derivatives. So the product rule says if f of x equals u of x times v of x, then f prime of x, so the derivative of f of x, will equal u of x times the derivative of v of x plus v of x times the derivative of u of x. So basically, it's just the first function times the derivative of the second function, and then plus the second function times the derivative of the first. Let's see how we can apply that formula. So here we have a function, and it's made up of 2x plus 3 times 3x squared. So I can essentially let u of x equal the 2x plus 3, and I'm going to let v of x equal 3x squared. So I need to find u prime and v prime. The derivative of u of x, if you'll remember the power rule in the last lesson, would just be 2. And the derivative of v of x would just be 6x. So now I'm going to take each of those pieces and just plug them into the formula. So the derivative of f of x is u of x times v prime of x plus v of x times u prime of x. So now I'm just going to multiply through. I get 12x squared plus 18x plus 6x squared. And if I combine like terms, I get 18 squared plus 18x, which is the derivative of my original function. Okay, let's try another one. So here we have y equals the square root of x plus 3 times x squared minus 5x. So I'm going to let this first part be u and the second part be v. And I'm going to rewrite this. So I'm going to write the square root as x to the 1/2. And I'm going to leave the x squared minus 5x alone. So now to find the derivative of y with respect to x, I'm going to take my u, which is 1/2 x plus 3, or x to the 1/2 plus 3, and then times the derivative of v, which would just be 2x minus 5, and then it's plus, and then it's v, which is x squared minus 5x, times the derivative of u, which would be 1/2 x to the negative 1/2. Okay, and then I'm going to FOIL this first part. So first, outer, inner, last. And I would get 2x to the 3/2 minus 5x to the 1/2 plus 6x minus 15. And then plus, now I'm just going to distribute the 1/2 x to the negative 1/2 to each of those terms. So I would get 1/2 x to the 3/2 and then minus 5/2 x to the 1/2. Okay, and now I'm going to go through and see if there's anything I can combine, which I can. I can combine the 2x to the 3/2 plus the 1/2 x to the 3/2. So that's 2.5 or 5/2 x to the 3/2 power. And then I see negative 5x to the 1/2 minus 5/2 x to the 1/2. And negative 5 minus 2.5 is negative 7/2 or negative 15/2. Make that look like a 15. And then we're gonna leave the exponent 1/2. And then I just have the plus 6x minus the 15. I'd like you to take a moment now to try this next problem so you can pause it and practice finding the derivative. And then when you're ready to move on, we'll move on to the quotient rule. So the quotient rule tells us that if you have a function equal to some expression, we'll call it u of x, over another expression v of x, where v of x we know cannot equal 0, then the derivative of f of x would just be v of x times u prime of x. Now we have a minus u of x times v prime of x. And then all over v of x squared. So it's basically the denominator times the derivative of the numerator, and then minus the numerator times the derivative of the denominator over the denominator squared. Let's see how we can apply it. So here we have f of x equal to some quantity, 2x minus 1, over 4x plus 3. And again, I'm going to let u of x be the numerator, and we're going to have v of x be the denominator. And I want to find the derivatives for each of them. So the derivative of u of x would just be 2, and the derivative of v of x would just be 4. Now if I use my formula, I'm going to have v of x times u prime of x. And then I've got minus u of x times v prime of x. And then it's all over v of x squared. Okay, so if I go through and I simplify, in the numerator I would have 8x plus 6 minus 8x minus 4. And I'm going to leave the 4x plus 3 squared just alone, so no need to expand that. And then I know the 8x's are going to cancel out, and I would get 6 minus a negative 4, which is just 6 plus 4. And then it's over 4x plus 3 squared. So I would have 10 over the quantity 4x plus 3 squared. So there's my derivative. For letter B, I have f of x equals 4x plus 6 over the square root of x. And we know from before that we can rewrite that as 4x plus 6 over x to the 1/2 power. Okay, so again, I've got my u of x in the numerator and my v of x in the denominator. So I'm going to have, for my derivative, it's u of x times the derivative of v of x. So the derivative of 1/2 x, using my power rule, would just be 1/2 x to the negative 1/2. And then I'm going to subtract v of x, which is, or u of x rather, which is so it should be v of x times u prime of x. V of x, oops, okay, I have this backwards. So it's v of x, which is x to the 1/2, times u prime of x. Okay, and then minus, and now I'm going to do u prime. So now I'm going to do u of x, and then times v prime of x, and that's the 1/2 x to the negative 1/2. And then all over v of x squared. Okay, so I'm going to go through and I'm going to distribute and multiply. I've got 4x to the 1/2 minus, and then I have half of 4. If I distribute that 1/2 x to the negative 1/2, so half of 4 is 2. X times x to the negative 1/2 would just be x to the 1/2. And then half of 6 is 3. And then it's just x to the negative 1/2. And then all over x to the 1/2 squared. So I get 4x to the 1/2 minus 2x to the 1/2. Those are like terms, I can just combine them. And then I have minus 3x to the negative 1/2. And x to the 1/2 squared is just x. And then that would be it. There's your answer. Okay, try pausing the video and practicing this problem, and then we'll move on and try another one. So here in example 3, we're going to have to use more than one rule because we're asked to find the derivative of this expression, but if you notice, it's made up of a product and then a quotient. So we're going to have to use both of those rules. So it has a product within the quotient itself, right? Okay, so we're going to have to use the quotient rule. So remember, the quotient rule would be v prime of x, v of x, times u prime of x minus u of x times v prime of x all over v of x squared. Okay, so let's write out here what we have. We've got our numerator, u of x, which is just this, and our denominator, which is that. Okay, so the first thing I'm going to do is write down my derivatives. Okay, so the derivative for v is much easier, it's just 7. But the derivative of u is going to use the product rule, right? So remember, the product rule goes something like this. It goes u times v prime, so v prime is 5, and then plus v times u prime. Okay, so now we have everything here that we need. We've got v of x, so to find the derivative, it's going to be v of x, and then it's times u prime of x, that's a 5. Okay, and then it's minus u of x times v prime of x and then all over v of x squared. Okay, and then I have to go through and expand some things. So I have 7x minus 9 times, I'm going to distribute and then combine like terms. So I would get 15 minus 20x, and then it's minus 20x minus 4. And then I'm going to have to FOIL and multiply. So that would give me, we'll do it in steps. That would give us 15x plus 3 minus 20x minus, so that's 20x squared, minus 4x, and then times 7. And then I've got the following. If I combine like terms, and then let's see, 7 times each of those. So 15 times 7. Oh, actually, let me combine something. So 15x minus 4x is 11x. 11x times 7 is 77x. And then 7 times 3. And then 7 times negative 20. Okay. And then we're going to FOIL again. So 7x times 11. Um, 7x times negative 40x. And then negative 99. And then plus 360x. And then I've got minus 77x minus 21, and then plus 140x squared over 7x minus 9 squared. And then let's see if we can combine some terms. So I see those two, we have to combine them. And I see these two, we have to combine them. And this one. And then we can combine this and this, right? Okay, so the 77s are just going to cancel out. If I take negative 280x squared plus 140x squared, I get negative 140x squared. And then I'm left with the plus 360x. And negative 99 minus 21 is negative 120. And then that's all over 7x minus 9 squared. Okay, try practicing a problem similar to it where you're going to need to use both rules. And then, of course, use the power rule mixed within. And then we're going to look at an application here of average cost. So let's apply some of the things that we looked at earlier. If you'll recall, the average cost per item is found by dividing the total cost by the number of items. The rate of change of average cost is called the marginal average cost, right? And that's the derivative of the average cost. So we kind of talked about in previous lessons, the word marginal refers to the slope because it's the average rate of change. So if the total cost to manufacture X items is given by C of X, that's our normal cost function, then the average cost per item is C bar of X. So anything with a bar over it stands for the average. And the average cost is just when you take the cost, the total cost, and divide by the number of items, right? So the marginal average cost is going to be the derivative of that cost function. So it's the derivative of what we get here. You should also note that the marginal average revenue function, r bar prime x, is defined as the derivative of the average revenue function. And the marginal average profit function is basically the same thing, except it's defined as the derivative of the average profit function, which again would be the total profit divided by the number of items. Okay, let's see how we can apply that. So suppose the cost in hundreds of dollars of manufacturing X motors is given by that function. The first thing we want to do is find the average cost per motor. Then find the average cost when 15 motors are produced. Okay, so to find the average cost, right, that's just going to be the cost divided by the total number of items. So my cost function is 3x squared plus 120 over 2x plus 1, and then I'm dividing by x. So this is just a division problem. So it's going to be 3x squared plus 120 over 2x plus 1 times the reciprocal of x, which is 1 over x. So that's just going to be 3x squared plus 120, and then I'm going to multiply the x, distribute it to the 2x plus 1, so I get 2x squared plus x. Okay, so that's going to be my average cost function. So now I need to find the average cost when 15 motors are produced. So I'm just replacing 15 for x. So it's just going to be 3 times 15 squared plus 120 over 2 times 15 squared plus 15. And when you work all of that out, you get about 1.7097. And remember that this is in hundreds of dollars. So if I multiply that by 100, that gives me $170.97. So that just tells me the average cost per motor is about $170.97 when you have a production level of 15 motors. Okay, now, if I want to find the marginal average cost, that means I'm dealing with the derivative. So I have to find the derivative of c bar of x, which is your average cost function. Okay, so we know that c bar of x is this function here. So I'm basically finding the derivative of that. Okay, so as you can see here, we need to use the quotient rule. And what I need to do is find v times u prime. Here it is. V times u prime minus u times v prime over v of x squared. Okay, so it's just going to be v, which is 2x squared plus x, times u prime. So u is the numerator, and the derivative of the numerator, if I use the power rule, would just be 6x. And then it's minus u prime, it's v prime times u, or v times u prime minus u times v prime. So u is going to be 3x squared plus 120, and then times v prime, which is 4x plus 1. And then it's all over 2x squared plus x squared. So that's v of x squared. Okay, and then the rest is just distribute and combine like terms. So we end up getting 12x cubed plus 6x squared minus the quantity, 12x cubed plus 3x squared plus 480x and then plus 120 all over the quantity 2x squared plus x squared. So we can cancel out the 12x cubes. If I combine 6x squared minus 3x squared, you get 3x squared. And then I've got a negative 480x and a negative 120. And then I'm going to divide by the quantity 2x squared plus x squared. And then again, I'm looking for the marginal average cost when 15 motors are produced. So remember, this is instantaneous rate of change, right? Because we're dealing with the derivative. So I'm finding C bar prime of 15. So I'm going to take 15 and plug it into the derivative. So I'm going to have 3 times 15 squared minus 480 times 15 minus 120 over 2 times 15 squared plus 15, that whole quantity squared. And I believe I have a typo here. This should just be... Oh no, it's correct. Yep, okay. So when you do that, you end up getting negative 0.0307. So now if it's a negative, the negative implies that the average cost per motor is decreasing. And it's decreasing at a rate of about, remember this is in hundreds, so about $3.07 per motor. And of course, it's approximate or on average. Okay, and that's at a production level of 15 motors. And that's it. In the next lesson, we'll look at another very useful derivative rule, which is called the chain rule. If you have any questions, please reach out. Have a great day, everyone.